we're going to be looking at evaluating piecewise functions. A piecewise function is a function that is composed of two or more parts or pieces. For example, a t-shirt company prices their t-shirts as follows. $12 per shirt if you order less than 100 shirts, $10 per shirt if you order more than 100. So how much does it cost for 20 shirts? And how much does it cost for 300? I have the two parts of my functions highlighted just so it'll be easier to talk about them. The first question, how much does 20 t-shirts cost? Well, 20 is less than 100, so that means that I'm going to be using that yellow function to figure out the cost. And the second question, how much does 300 t-shirts cost? Well, 300 is more than 100, so I'm going to be using the pink function. So here, f of 20 is going to be found by multiplying 12 times 20. So that's going to be $240 for the cost. And the second question, how much does 300 t-shirts cost? So f of 300 is going to be 10 times 300. So that's going to be $3,000. So that's a real-world example of where you're going to be using piecewise functions. Okay, let's look at some problems like you're going to see in my math lab. F of x equals 2x plus 4 if x is less than 0, and it's going to equal x squared plus 2x minus 3 if x is greater than or equal to 0. So my first problem I need to figure out is f of negative 5. Well, where does negative 5 fall? Does it fall within this yellow category or within the pink? Negative 5 is less than 0, so I'm going to be using the yellow function. So I'm going to be using the 2x plus 4. So 2 times negative 5 plus 4. And that's negative 6. Now f of 0 is a little tricky because you have 0 over here on the end of both inequalities, but the one that I'm going to be using is the pink because this inequality here says greater than or equal to 0. So I'm going to be using the pink function. So I'm going to put 0 in place of x. In this last problem, x is 3. Well, 3 is greater than 0. So I'm going to put 3 in for x. You have 3 squared plus 2 times 3 minus 3. And that answer is 12. Okay, with problem 2, the first thing I'm going to do is to highlight each of these parts of my piecewise function just so it's easier for me to talk about. And I'm also going to do something just a little bit different here to explain this one. Now you can see that my function has 3 pieces. So what I'm going to do is to draw a number line and color code my number line. The two numbers that I'm interested in here are negative 3 and positive 2. Now, if a number is less than negative 3, I'm using this part of the function that says negative 3x minus 1. So less than negative 3 is this part of my graph on forever toward infinity. And I do include this negative 3 with this yellow part of my graph. The pink part of my graph is going to be from negative 3 to positive 2, but I don't actually want to touch positive 2. I can get as close to it as I want, but I don't want to touch it because the green part is actually going to be covering up that 2. If my input value is 2, I'm going to be using the green part of the function to evaluate. Okay, now I want to figure out where these numbers lie on my number line. Well, -6 is in this part of my graph. So it's in the yellow part. So I can color code -6 being yellow. -3 is right in that yellow part as well. It's right on the end point. -1 is in between -3 and +2. So that is going to be my pink part of the function. And 5 is in the green part of the function. It is over here toward the right. So you put -6 into the function. You are putting it into this part up here that's going to give you -3 times -6 minus 1. And that's 17. When I put -3 in, I have -3 times -3 minus 1, and that's 8. F of -1 is going to be 2 times -1 plus 5, and that's going to be equal to 3. And for f of 5 is -4 times 5 plus 2, and that equals -18.